This short video is going to explain what we mean when we talk about resultant vectors. First of all, if there is only one force acting upon an object, it is feeling force in only that direction. That is illustrated here as one student uses a single rope to pull another student across the lab floor. It will move in the direction of the force of the vector. And now let's take a look at what happens when we have two vectors working on that same object. In this case, we have both vectors that, if we can imagine, are at equal angles in relationship to the object, the student in the desk. But in this case, they are at opposite angles. So they're equal but opposite, and they are going to work with the same amount of force. What happens? The object actually feels the same vector that it felt in the first place. It's moving in a direction that is in between the two. So even though the object was not being pulled straight forward directly, that is what it felt, and that is the direction in which it moved. Now what happens when we have two vectors? We're going to say they're the same angles that they were before, equal but opposite. But the vector on the right with the red sweatshirt is going to pull with much more force. Now the resultant vector pulls the student in desk at an angle that is neither the vector to the left or the vector to the right, nor straight. It is a summation of all the x and y forces that those two vectors created, and you come up with a third vector known as the resultant vector, and that's what we want to calculate when we have multiple forces working upon an object.